Hello, my name's Pete and we're here in Lenovo Studio today and we've got a great guest on today. It's actually my fellow colleague, but before we go into that, quick introduction to myself. I'm Pete Hill, I'm one of the co-founders of Kudo. And as I said, we have our illustrious CEO and founder here, Matt Hawkins. Matt, a little bit about yourself?
Yep, hi there. My background is the data center and cloud industry for the last 20 years. We built a lot of the core infrastructure across the UK, so that's what we've been doing for a long time. And Kudo, which one of the things we're talking about today, we are a data center or an infrastructure marketplace for infrastructure that needs AI, basically, where it powers artificial intelligence, and we make the cloud industry more sustainable.
Fantastic. Okay, save on that part, and we'll come back to that a little bit later. I think today will be really good to talk about some of the wider things that we're seeing within the industry, right? So we're seeing this day in, day out, and a key part to start with is kind of the stress on cloud infrastructure and cloud services in general due to this explosion in AI. So I wanted to kind of start there first and talk about some of the hyper-growth use cases within AI. What exactly is happening? Let's go with that. What is actually happening that's driving this crazy demand on cloud infrastructure?
I mean, unless you've been under a rock, you'll have known about AI and what's been happening over the last year. Really, it's kind of ChatGPT, as we all know, kind of kicked off that craze. AI's been around for a long time, but the best way to look at the growth of the market is kind of look at what Nvidia's been selling, and correlated is their share price.
Yeah. This is not financial advice.
So, I mean, if you go for the last quarter of about a year ago, then they were doing about $4.5 billion per quarter of sales. Mm-hmm. 12 months later, they're doing 18 billion of sales. And what it's all come from is the adoption of artificial intelligence. What's happened is, like I mentioned, had ChatGPT 3.5. That was kind of in the background for a while. A lot of people had never heard of kind of 1 and 2 and 3, which were the earlier versions. 4 came out. All of a sudden, people realized the impact and what it could do. And it became available to the average Joe in the street, really. And then that was the awareness. And then at the same time, there's actually been a lot of open source projects that have been built. And these then started to become public. And because of the awareness on this, all of a sudden, the open source projects have kind of become adoption. And people are now trying those applications. And all of a sudden, you've got growth everywhere. And once you've got interest in that space, you've got VCs that want to invest in that space, and that's just accelerated it. So you've kind of got this rolling momentum of really it's exactly what happened when the internet took off in the late 90s. People started using it. I mean, if you ever watched whatever was the equivalent of Good Morning Britain back then, people were talking about email, this is never going to catch on. We've got fax machines, so we've sort of gone through that tech cycle again, but this is the next biggest thing.
So we hear about. I mean, machine learning has been around for years. We talked about deep learning and there's neural networks, and you've got natural language processing. So all these different subsets, I guess, of AI. But the hot topic seems to be generative AI at the moment. So could you? I mean, you've talked about ChatGPT, but could you give us some examples of what is possible with generative AI?
Yeah, I guess if you look from a adoption perspective of people using it for a day-to-day, you've got the chat element, which is what came out first. That is getting more and more intelligent as we go literally each month and new releases come out. It's based on, or a lot of it's based on number of parameters. So this is kind of the size of the training set. It's like, how much computing can you put towards building the brain, essentially? And that's getting bigger and bigger as more and more hardware is bought. And as more hardware goes into the system, people can build bigger systems and they can code bigger systems. So it's based in billions of parameters. So this brain is getting bigger and bigger, and people are building bigger brains, which means you can have more intelligent conversations. So it started off, with text, and everyone was comfortable with that. And then you've got other platforms where they then start doing the video images actually came out next. With images, you've got ones like Stable Diffusion, which is open source software, and a lot of people use that. And that's where you can kind of design your own brain and train it as you want in a specific area. So it could be anime, it could be cartoons, it could be nature. but you kind of train it in your areas, and then you can use it for those purposes. But then also you've got other platforms where OpenAI have done it now, Google have done it, Microsoft have done it. It's where you've got access to the actual image generation. And you can build your own images, and it's getting better and better. And then what we've now just seen with Sora come out, which is OpenAI's new platform, which isn't public yet, but the videos are public. And all of a sudden, you can now create images, but that can take videos rather, that can take hundreds of frames, so hundreds of times more compute to build those frames. But you're now seeing basic text. A few months later, you've now got images. A few months later, you've now got videos. And if you look where we were for software like Midjourney, for example, which is one of the big platforms, go back 12 months, those images were just about recognizable to being people. Now, 12 months later, you can't tell, or you can barely tell the difference that it's artificially generated. So the speed, like logarithmic growth in this space is incredible.
Yeah, that's incredible. And I guess from what you've explained there, you can quite easily then see the kind of stress on the infrastructure in the background, or the demand for the infrastructure, shall we say? Because if you're going to be creating a video from a text input, then there's an awful lot of computing power that needs to go into that, right? And that's the talking to the service, which has already been trained. So it's already taken a lot of computing power in the first place to be able to get to that point of being able to talk to it. Is that kind of correct?
Yeah, that's exactly it. So there's a lot of upfront computing to kind of build the brain, if you think of it like that. Yeah. And then after it, there's a lot of computing to talk to the brain and translate what you're asking into the results that come out of it.
Wow, okay. And do you see that growth continuing? You kind of alluded to an inflection point, and now we've hit that snowball effect. Is it going to plateau, or is it just going to keep going and going and going?
There's certainly no sign of it plateauing at the moment. A good way to look at it is at the size of the market. The market at the moment is considered about 200 billion, depending on which reports you read. It's considered by the end of the decade, it's going to be 1.8 trillion. So that growth in AI is just going to continue for the rest of this decade. But it's not just the amount of objects and things that we do from a day-to-day perspective, it's the intelligence that grows at the same time. So everything that we do, at the moment is becoming more and more is getting involved with AI. But you look at where we are in 4 or 5 years' time, pretty much everything you do every day is going to be
Should we be scared? Or maybe that's a conversation.
I think that's a separate conversation, but yes, marginally.
Okay, I must admit, I listen to because you can do text to music as well, and I've listened to a few. There's one, there's Oasis or something like this, right?
Oh yeah.
So Oasis, obviously, and they've taken taken some of the voices and stuff from previous songs and the notes and everything. They've compiled it and they've created this EP. So this short album of 4 tunes. Spot on. It's really good. Anyways, not an advert for that. And I'm sure Noel and Liam are not very impressed, but it was really good. But it does show you the kind of the power of it in that sense.
And then now on that element, they're actually now linking with brain scans. And then these are kind of off-the-shelf brain scans as well that you can do. Is that you can now start to scan the brain, and if you think of a tune, it will read the tune that you're thinking of and actually play the music. Wow. And they can do the same using stable diffusion, which I mentioned. You can do the same with images. So you can read on your brain. Originally, it was done with CAT scans, but they're now getting to the point that you can do it with sensors.
Well, that's a really good point, actually. If we think about, because we've got the fun aspect of it. I want to create this very creative image from text, or I want to create a bit of music, I want to create a bit of video. But from kind of use cases in other industries, like medical industry, for example, I've seen it where surgeons are starting to use stable diffusion technology to be able to produce like slices of an organ, as an example, so they can really understand how a disease is kind of going through that organ and how best to kind of execute surgery on it, if you like. From there, so the use cases seem to be far and wide, right? It's not just the kind of the fun end creative stuff. It's all industry really. It's covering manufacturing, industrial. Is that what you're seeing as well?
Yeah. So there's a thing called digital twins, where you kind of create a replication of the real world, but it can be anything. It can be a body, it can be a factory, but it enables you to simulate all the way down to the cells in the body, or if you're in a factory, all the way down to a nut and bolt that sits in a robot arm that you're trying to build. But it enables you without physically having to spend the money, apart from spending it on compute, obviously, or development. You don't actually need to physically build those environments. So it's much more efficient from an environmental perspective, a cost and a time perspective. And because there's so much data there now, we can pretty much real world simulate those things where it takes into account gravity, fluid dynamics, airflow, everything. So it's quite fascinating on where we're going with it.
I kind of almost feel like I'm on Star Trek and we're just scanning that.
Yeah.
Excellent. So let's move on a little bit, because we've talked about the kind of the demand for the infrastructure that's out there, and anyone within the cloud industry is seeing this kind of growth, particularly in that sector, right?
Yeah.
What does that exactly mean for the environment? And what I mean by that is that there are people out there that are very, very pro AI, and they're saying that the technology has the potential to reverse climate change, right? So, in some of the calculations that we're doing, or some of the technology that it will invent or develop or evolve or something along those lines, how it will allow us to kind of optimize different things like air quality, et cetera, has the potential to be able to help with climate impacts. But then at the same time, we're talking about an enormous growth in the amount of computing infrastructure that's required. And all of that computing power obviously needs electricity. That electricity has to come from something, right? So what is the climate change? What are the kind of solutions out there to stop this just going out of control and creating this huge kind of carbon bomb from the data center industry?
Well, I think if you look at where we are today, the cloud industry produces between 2 to 3% of the world's carbon emissions, which is a fair amount. But if you look at the growth and of artificial intelligence, the compute needed for that, the amount of really electricity that's needed is between 4 to 5 times in an equal amount of space in a building. And they're looking at, if we're 2 to 3% now, it's considered in the next decade, we could be at plus 10%, as in over 10%, that carbon emissions are produced by this industry if we don't make a lot of changes in place. If we carried the way on where we are, then that's where we're going to end up.
Yeah.
Because if you look at things like electric cars, they're going to be replacing petrol, and there's lots of other environmental changes that are all being improved. If we don't improve the cloud industry, this is going to be one of the worst spaces. So it's really key that we get that bit right. And there is constant growing demand on the electrical grids for energy, especially as everybody moves to electric cars. There's not enough power in the grid, or cabling and connectivity inside the grid to be able to service just the electric cars, let alone the growth from artificial intelligence. And we're expected to increase by 4x from today to 4 years' time on the amount of energy that's used for AI for that industry. So you've got these mix of balances that's a bit of a real problem at the moment. And obviously we all want to get off coal and gas and these other sectors. So it's really key that we work with sustainable providers around the world, to be able to capture that and actually using it for the data center industry.
And where those sustainable providers, where are they getting their power from? How is it sustainable?
Yeah, the 3 main areas. One is hydro, which is from water, typically water dams. They will be often big dams in the hundreds of megawatts or even gigawatts, so the equivalent of thousands, tens of thousands, sometimes even hundreds of thousands of homes that power those areas. But you've got a lot of stranded power, which is what it's called, around the world, where you've got more power being generated than what can be used. So when you build a dam, you typically oversize a dam, because you don't want to build a dam and then it's like, oh, damn, we've got to build another one.
No pun intended.
Exactly. So what they do instead is they build well ahead and they massively oversize it. So you have all this spare capacity. So they're an ideal location to put data centers. Solar is quite often built and matched to the actual data center itself. And then wind, but the problem with solar is, you've got a bell curve during the day and then it drops back down but now you've got batteries and lithium battery recycling from electrical cars and other vehicles is making that industry more efficient. And then you've got wind. So obviously that's the other one, and wind turbines. Wind is actually a fantastic solution, but the problem is a lot of people don't want to see that in their, when they're looking out their window or looking out to sea. So planning is a problem with that in finding locations that can wind. And the last one is, the sea, tidal. But tidal has got its challenges kind of from an installation and maintenance perspective. But they're the different types of energy that you can connect to. And really what we need to do is have more data centers connected directly into those, because when you have power that's going through the electrical grid, you've got a lot of losses that go through it. But also over there, you've got a bit of gas and a bit of coal and you're mixing it all up. If we can continue to build sustainable infrastructure and match it directly, it means that you don't have to keep upgrading the grid.
Right.
And that grid can then be used for other purposes, which is obviously cars and people and homes and everything else. So really we want more data centers around the world in sustainable locations which are connected into grids or connected directly into the power itself or as close to the power generation as possible. And that's really what you need to be able to sustain this growth and not have the impact of, right, we need to burn more gas, we need to, whatever else solution is that's,
what about things like, it's not a renewable power, but what about things like gas flaring, where they're taking the methane, instead of flaring that methane up into the atmosphere, which is 20 times worse for the atmosphere than carbon dioxide.
Yes.
But they're taking that out of the air, essentially, and converting it into electricity. Are you seeing that? That's another type of stranded asset.
Yeah.
In a sense, is it?
Yeah. At the moment, they'll literally either release it directly into the environment or they'll burn it, as it's the two. Generally burn it, because you don't want too much gas just in the environment. But yeah, that's incredibly bad for the environment. But there's no financial incentives for these companies to do anything with it, and the penalties are tiny. So they just burn it the majority of the time. So yeah, there's providers that basically what you need is you connect it into a turbine, a generator, and then you can convert that directly into electricity. That reduces the carbon emissions by over 70% of what is being done today.
Yeah.
And then that electricity comes off. But that doesn't work. If you're going to build a big 100 megawatt data center facility, that doesn't work. But if you're building 1 or 2 megawatts around the place in lots of locations, significantly better for the environment. And it's also low cost because you've got no cost of production, because it's already exists there. And really, you're just reducing the carbon emissions and putting a generator with it. So yeah, that we do need to do a lot more of those, definitely.
So it lends quite well to kind of a widely distributed, maybe even like a kind of edge computing network, right?
It's perfect for an edge computing network. Or you just need the site itself and you need fiber, resilient fiber to get connected in, and that's it. That is a perfect site to have a compute, and a few megawatts at a time. But there's thousands of these locations across the US, for example, many across Europe. If you place those around there, that's enough. Even just filling those, is enough to sustain a lot of the growth.
So how, on the wind side of it, you were talking about the big wind turbines being an eyesore. Remember when you used to get to the seaside where you're younger and you blow on the thing, looks like a sunflower. Why don't they just decorate them, dress them up like that?
Maybe you need to put that suggestion in.
Maybe.
You're the first one to patent it, because I've not seen any of those yet.
So regulation is going to be something that comes in if it's not already in now. And I'm talking more on the environmental side of things here, right? So we ESG, SDG, these are all kind of familiar terms to businesses out there, particularly over a certain size where they have to have those policies in place.
Yeah.
Are there any other kind of regulations that are coming in that we should be aware of that's going to impact it, which is going to drive people more towards these kind of sustainable service provider type environments?
Yeah, obviously you mentioned a couple of two, but they're more principles, of how these companies work. But Scope 3 is the first time we're bringing in at serious scale, a way that everyone is essentially regulated or penalised if you don't follow those regulations or rules. So it's more applied to larger companies. But what we're doing at the moment, the way corporates are set up at the moment, or the way the regulations are set up at the moment, is that you are meant to monitor your own emissions as a company. But then what really happens is people secretly kind of, right, we can offload that to someone else, offload that to someone else. And you don't have to account for emissions of everyone else that you're offloading it to. So even when you're importing and exporting, if you do that, you actually essentially offload that emissions responsibility to someone else, and then they do the same. So it's really a bit of a mess in that industry. So what Scope 3 is bringing in is, as a corporate entity, you then also have to report on the emissions of everyone else that you work with. So if you've offloaded that element, which could be compute, and you're using that third party, they need to be able to report to you what Scope 3 emissions are. So they need to say, right, you've created, let's say it's 1,000 GPUs for a month, for example. This is X number of tons of CO2 that you've produced. So all of a sudden, it's really important, the people you choose to work with, what are carbon emissions and how environmentally friendly they are as a company. So from a cloud perspective, there are lots of providers out there which they have a mixture of gas and coal but also a bit of renewables as well, or they're buying carbon credits. But carbon credits doesn't really cut it. It's you can buy carbon credits, but it doesn't have anywhere near the positive effect in the environment as if you just bought it as renewable in the first place. So it's not great buying something that's running in coal and then I'll buy some credits because that's all right. So that's one of the things that's going to change, and everybody needs to be able to report that. So in different parts of the world are based on different timescales and when it's being released, but a lot of it is coming out this year.
So that kind of reporting becomes almost as important as your kind of business P&L, in a sense. For those industries and all those companies over a certain size now, they have to report on it now. But if those size companies are reporting on it now, that means it's that barrier is going to come down, or that qualification, shall we say, is going to come down, right? And eventually it will be all businesses of all sizes.
Yeah. I mean, even if you're a small, mid-sized company at the moment and you care about ESG in the first place, you should know when you put work and with somebody else, you should know what the emissions are and what that effect is from your business. So you might not regulatory need to do it at the moment, but from an ethics perspective, you should know that.
Wow. Okay. Fascinating. Okay. All right. So tell us about Kudo. I mean, what we've talked about the kind of stresses of cloud infrastructure due to the explosive growth of AI. We've talked about the environmental impact. So what is Kudo, and what are we doing to to solve those problems?
I mean, Kudo is a team of people that have come from the data center and cloud industry and run infrastructure and saw the negative impact of this industry. So what we did was when Kudo was set up is we wanted to increase sustainability of the cloud industry. That was the principle behind it. And enable all sustainable cloud providers around the world to be able to sell their services into the market. So we built, think of it like Airbnb, but a sustainable version of Airbnb, where you go onto a marketplace and you can access all the available sustainable computing around the world. So these are companies that are running either in renewable energy. A lot of the things that we've talked about today, it could be in flared gas, it's running on solar or wind. There's heat reuse projects in there as well. So this is where the heat from the servers is actually used for things like agriculture, heating swimming pools, heating public premises, hotels. And where you're reusing the heat, it's actually carbon negative. So at the moment, gas is being burnt or electricity is being used to heat these locations. You take the heat that comes out the back of the servers essentially and duct it in. So it's all about how do we reduce the carbon emissions? How do we not get to that 10 to 12%? And because there are, if you look from an AI perspective, there's only so much capacity coming into the market, and it's all sort of getting distributed amongst everybody around the world. So what we do is we work with all those providers around the world to be able to access all of that computing resources. So you might need a huge amount of workload, but actually you could put some here and some here and some here.
So it's fair to say we're aggregating all of those service provider environments around the world are potential suppliers to the Kudo compute marketplace. This kind of giant GPU marketplace, if you like.
Yes. Okay. Yeah. So You know, we work in different sectors. Sometimes we work with actually half the companies that sit inside those sectors, and they don't traditionally need to be, you know, actual cloud providers. They need data centers and renewable energy and infrastructure, but we have the entire tech stack. Anyone that, you know, if you were going to buy a server, for example, and you were running it in a data center, and you've got spare capacity and it's sustainable, you can install our software and tech stack and instantly become a cloud provider. So we've enabled anyone to be a cloud provider as long as it's sustainable. So think of it like if you've got a car and you want to be an Uber driver, you just download the app and then you're an Uber driver. So we've literally made it virtually that simple to be from a cloud provider perspective, as long as you match what we want from an ethics and sustainability perspective. So we have companies that previously never sold cloud, but they've got data centers and they've got capacity. They install our software, and then all of a sudden they can become.
Well, that's a very good point, actually. So there's certain types of suppliers out there which have been operating very compute intensive farms. You know, maybe they've come from the Bitcoin mining world as an example, and extremely good operators, right?
Yeah.
And you know, they're in these low cost, renewable, high density power zones because that's what they've needed to run those environments before. And now they're seeing this wave of AI, and you know, as we know from that type of supplier, that type of operator, they have a risk appetite and they have a capital appetite. So they're looking to get into this kind of AI and high performance cloud and compute and stuff. But as you said, they've never really sold into that industry before. So in effect, Kudo Compute can become that window for them, can become that route to market.
Yeah, exactly. And it's also used by traditional sustainable cloud providers as well, and it gives them a new route to the market into the world.
Excellent. Okay. All right. Excellent. So where does someone go if they want to find out more about Kudo Compute, the platform?
I mean, you can actually go on there, kudocompute.com, and you've got access to sustainable computing resources anywhere in the world. On average, it's about 75% less than hyperscale providers.
In cost-wise? Or?
Yes, yeah, from a cost perspective. So it's more sustainable and lower cost, and it's at scale. So, you know, we work with companies with, you know, huge amounts of compute that need to deploy, as well as someone that just wants one server and, you know, wants to use it for a few weeks while they're building and testing.
Brilliant. Well, thank you very much, Matt. It's been a pleasure sitting here today and asking my boss questions.
That's right. Pleasure.
So if anybody would like to find out more about Kudo Compute, www.kudocompute.com. There is a link below, and we'd love to hear from you. Thank you.